went to section 3.3b, which is continuing our understanding of equations with two variables. So take this equation. For example, it's got an x variable and it's got a y variable. And what we're going to look at here is how we could make a table of xy pairings that would correlate with this equation. And also we're going to make a graph directly from this table. So I don't think it's too big of a stretch right now for you to understand that this equation is describing a relationship between the x variable and the y variable, namely that y will be equal to -2 times x plus 3. So, you know, whatever x is, remember x you should sort of treat, even though it's a variable, you kind of treat as like a number. So whatever x is, you would multiply it by -2 and then add 3 to equal what y would be. But of course, with x being a variable, it can vary what x is. See what I did there? So making a table for a two-variable equation is pretty simple. You normally just kind of pick, I'm going to say random x values, but sometimes it's not so random. These are some very, very, very common, like this group of numbers is, I would say, pretty common looking group that you would pick to kind of plug in for x, you know. So sometimes they're just kind of given to you, a certain list of numbers already in the x column. Sometimes you have to come up with those values on your own, but that's what's basically happening, you know. Like, we're going to come up with a bunch of pairs, and then let's just get to it, I guess. If we plug in -3 for x, if we plug in -3 for x, what would that make y? Right? And wouldn't that be like -2 times -3, which would be 6, and then you would add 3 to that to get 9, correct? As in, y would equal, I'll even write this out at least once here. If x was actually just said to be -3, then you would just do all this because that's what y would equal. And so -2 times -3 is +6, and then +6 plus 3 is 9. So when x equals -3, y equals 9. Okay? But what if we let x equal -2 instead? If we let x equal a different number, aren't we going to get a different answer for y? So -3 and 9 make a good pair, as in like xy pair. But if we plug in -2 for that x, you know, what are we going to get instead? This will be, let's see, -2 times -2 will be 4. And then +4 plus that 3 will be 7. All right? And so, oops. Let's see, so that would be 7, sorry. And so there's another pairing when this would be x, this would be y. So these are together, just like -3 and 9 are together as a pair, as an ordered pair. If we were to plug in -1 in for x, it would be -2 times -1, which would be +2, plus 3 would be 5. And if we were to plug in 0 in for x, if x were to just equal 0, then y would equal -2 times 0 plus 3. And -2 times 0 plus 3 should be 3. And just finishing off this table quick, if you plug in 1, you end up with 1. Funny enough. Just a coincidence. And then if you plug in 2 for x, then y would equal -1. And if you were to plug in 3, you would end up with -3. All right? And now, I don't know, just to kind of try to be extra clear, these are definitely not the only numbers you could plug in for x. You know, what other numbers could you plug in for x? Or how many numbers are there to plug in for x? Isn't there an infinite number of values? And they don't even have to be integers. You know, they don't even have to be nice integers. Couldn't I plug in 1.5 in for x? Couldn't I plug in -pi for x? Couldn't I plug in 57 over 101 for x, like the fraction 57 over 101? Couldn't I plug in that nasty number for x and I would get some answer to go along with it for y? Yeah. So these are just, I mean they're random, but they're not so random, I suppose. But you know, you could really actually plug in any number you wanted for x to get a y value that would go with it. So if x equals something, then y will equal something. And this, you know, this -3, what color should I use? Let's go with purple, I guess. Just to kind of, you know, this -3, 9 pairing is actually an ordered pair, a set of coordinates, x, y coordinates, that together make one point. So -3, 9, I could plot as a point over here and make a graph for this table, and therefore a graph of this equation. So as an x coordinate, because remember, this is the x-axis and this is the y-axis, so the coordinate of x, the x-coordinate, -3, y-coordinate of +9, there is that point. Okay? And I don't know how many different colors I have here, but -2, 7, I'll use a different color. That would be, let's see, -2 x-axis. There's that point. You know, and then -1, 5 would be another pairing. So there's that point. And 0, oops, I pressed it. So 0, 3, so let's say we go 0 left or right on the x-axis, And up 3, so right there. So, I mean, the rest of them, right? 1 comma 1, 2 comma negative 1, 3 comma negative 3. These are all points on the corresponding graph. So 1 comma 1 is right there. 2 comma negative 1 is right here. 3 comma negative 3 is right there. You know, so those are all the points that we just generated by making this table. But like I said, and I'm going to make not the biggest leap here, but like I was talking about a few minutes ago, these are not the only numbers you could throw in for x. Like, not even close. Like, you know, there's all, like, you could plug in 6 and get some corresponding y value, you know, to go with 6. You could plug in negative 10. Heck, you could plug in, like I said, 1.5. You know, so let's just really quick. If I plugged in 1.5, what would I get? You know, negative 2 times 1.5 plus 3. So this would be negative 3 when you do negative 2 times 1.5, 1.5, plus 3, and you're going to get 0. So guess what? Another point would be 1.5. Let's see, that's 1.5, like right here. And then the y coordinate would be 0. So it would be like right there. And there's like a bajillion other points. And so really what this amounts to is we need to connect the dots. Because you can't just keep plotting points forever. You know, there's an infinite number of points that are going to make up this entire graph. Like if you wanted a graph, like the entire graph for this equation, it would be like an endless number of points that all pack together to make this line. So in other words, I mean, basically we're connecting the dots. Like that's what you're doing when you're connecting the dots. You are just kind of like taking a major shortcut to plotting like every single dot you could possibly make. You know, like look, there's dots. Look, there's dots everywhere that all have a pair of x and y coordinates, but for the shortcut is just kind of connect the dots, and this graph is just going to be a straight line that goes on forever in both directions. Okay? And yeah, so I guess just a quick summary before moving on. This equation, you know, you can generate a table of xy pairings, which we would call these all solutions. You know, negative 3 and 9 together solve the equation. So in this case, when there's two variables, it takes a pair of numbers to solve it, you know. So negative 3 comma 9 is one solution, negative 2 comma 7 is another solution, negative 1 comma 5 is a third solution. Here's another solution, here's another solution. And the graph is just a picture of all the solutions. All right? Now for the rest of these notes here in this video, we're going to kind of go in reverse and take a table that's already been sort of filled out and see if we can come up with the equation that would sort of correspond with this table, you know, based on a pattern. So here we go. Like, what equation would, like, what would the equation be where if you plug in -3 for x, you end up getting -6? And if you also were to plug in, or instead, I guess, if you were to instead plug in -2, you'd get -4. But if you would plug in -1 instead, you'd get that. Or if, in other words, what's the mathematics, like all the operations, adding, subtracting, multiplying, and dividing? What operations would you do to -3 to make it -6? That same operation or operations to make a -2 into a -4, which would also make a -1 into a -2 and a 0 to remain 0 and 1. Okay, so what math are we doing to the x values to make them the corresponding y value? Well, there's not much more I can say to really help. You just have to think and figure it out and kind of guess and check a little bit. And it turns out that we're always taking these numbers and multiplying them by 2. Because -3 times 2 gets you this. -2 times 2 gets you this. -1 times 2, bam. 0 times 2, boom. This times 2, this times 2, this times 2. So the equation would be the x's times 2, or it's better to say 2x. So the equation for this is y equals 2x. How about over here? Pause the video and think about it if you want to, or I think you should. What are we doing to the x values to change them into the corresponding y value? Well, it looks like, especially when you look down here, it gets even easier. It looks like we're always taking the x and we're adding 4. And if you do the x plus 4, it'll equal the y. And that holds true for all of these pairs. And so this is the equation. Number 3, again, you might want to pause the video and then restart it after you've thought about what the equation might be. So it turns out that what we're doing here is we're just taking all the x's and we're multiplying each one by -1, right? And so the equation you could think of, at least at first, as like y equals -1 times x, but you don't really write that. So just writing y equals -x would do the trick. Once again, pause the video for a moment and see if you can figure out what equation would model this table. Well, it looks like, especially again when you look down here, it looks like we're always adding 5 to whatever x is and to equal y. Same deal, pause the video and for the next one. For this one, it looks like what we're always doing is multiplying -3 to whatever x is for it to equal y. So this equation, it's like y is always equal to -3 times the x. And that would work for that one. Same idea, right? And I believe these are the final 2 examples. So why don't you just pause the video and do these final 2 before unpausing. Let's see here. For this one, it looks like there's going to be more than one operation. It's not like we can just multiply. Or can we? Maybe we... Let's see here. If you, let's look at this pair. if you do this x and you subtract 8, maybe that's it. Maybe I was wrong. There's a lesson for you. Think things through, because now that I'm looking at this, when I'm really looking at it, when you take this and you subtract 8, that's what you get. When you subtract 8, that's what you get. When you subtract 8, subtract 8. All right, so it looks like, whoa, I don't like that x. Stupid pen. What's going on here? I don't like these extra tails. So it looks like you always subtract 8 from the x, whatever the x is, for it to equal y. Let's see if I do better with number 4. Let's see here. Is this a repeat? Is this a repeat? I think so. Well, I'll check that in a second, but you could go with an idea like based on this one, like or let's look at this one, just to show you it doesn't really matter. I'll look at this one and say, okay, if I subtract 4, I get -2. So is it x minus 4? No, because if you subtract 4 from this one, you don't get that. And if you subtract 4 from this one, you don't get that. So the pattern, if you looked at this one only, you might think the pattern is x minus 4. But it's not, so maybe you think about what could you multiply by? Well, what would you multiply to that to get that? You would multiply by -1. And does that pattern hold for, say, this one? When you multiply by yes. How about this pairing? If you multiply that by -1, yeah. If you multiply 0 by -1, you get 0. Multiply. So again, it looks like this is the whole -1 times x, or just -x. So, I mean, hey, keeping you on your toes, right? It was kind of a repeat. And that's that for this section of notes in this video.